So algebraic method solved for minimization problem. Minimize z equal to 7x1 plus 5x2. These are the constraints. So here we give greater than or equal to 4. This is greater than or equal to 10. So this can be written as like this. So here we have x1 plus the first constraint x1 plus x2 greater than or equal to 4. So x1 plus x2 can be 5, 6, 7, 8 or more than that. If it is 5, then some value has to be subtracted. So we are introducing one variable, extra variable called x3. We put minus sign. So x1 plus x2 minus x3 equal to 4. So we have to convert each and every constraint which is having inequality constraint and equal to 0. Make it the equation. So 5x1 plus 2x2 minus x4 equal to 10. So x3 and x4 are called negative slack variables or surplus variables. Now as usual, in the minimization problem, we start with x3 and x4. These are the basic variables, and non-basic variables are x1 and x2. So find the value x3, x4. So both have negative values. It's infeasible. So go for different combinations. x1, x3 as basic variables, x2, x4 are non-basic variables, and find x1 and x3. So x3 got negative value. So it's violating our rule. So as per our problem, all x1, x2, x3 and x4 are greater than or equal to 0. So we cannot get a negative value. So it is infeasible. For other combinations, we find x1, x4, x2, everything, right? So find z. This is positive value. So this is basic feasible solution. So here, the third step we have z equal to 28. Fourth, we have z equal to 25. This is also a basic feasible solution. Fifth solution is having negative value, so infeasible. The last solution, we have x1 equal to 2 by 3, x2 equal to 10 by 3, z equal to 64 by 3, that is 21.3 approximately, right? So among all 6 values, in the 6 steps, we have only 3 solutions, 28, 25 and 21.3. So our problem is to minimize z. So choose the lowest one. So this is the optimal solution. So the corresponding x1 and x2 values are the optimum values, right? So x1 equal to 2 by 3, x2 equal to 10 by 3, z equal to 64 by 3. Next one is simplex algorithm or simplex method. So in algebraic method, we are solving some problem. So we need 6 steps. So we are going to solve the same problem here, but the steps are simplified and we need only 3 steps here. It depends on the problem. Right? So let me take the same problem which is already discussed. There is a maximize z equal to 10x1 plus 9x2. The constraints are same, and x3 and x4 are slack variables. Next, okay. This is a table, so it can be solved in a tabular format. The tabular format, the first thing is Cj. Cj is nothing but coefficient of objective function. So the objective function is here 10x1 plus 9x2 plus 0x3 plus 0x4. So the coefficients are 10, 9, 0, 0. So it can be written here 10, 9, 0, 0. Basic variables. Basic variables, we don't write anything now. We are going to fill afterwards, right? CBI, suffix I. CBI is nothing but coefficient of basic variables. Okay, it will be there. Here we are filling x1, x2, x3, x4, right hand side, equation right hand side, and the ratio I will discuss afterwards. Now, if we we go to the equations, this is the equation. So here we have to fill this violet colored, right, space. So here the coefficient of 3, for x1 it is 3, for x2 it is again 3, for x3 it is 1, for x4 it is 0. So 3, 3, 1, 0. Go to the second equation, 4, 3, 0, 1. 4, 3, 0, 1. Okay. As discussed earlier in the algebraic method, it is very easy to make x3 and x4 as basic variables, right? So we are following the same thing here. So we are assuming x3 and x4 are the basic variables because we are going to find initial solution, this iteration 0, or you can say initial solution. For finding initial solution, make x3 and x4 0. Right? So put the x3 and x4 here, and the coefficient of x3 is 0, coefficient of x4 is 0. Okay. Now we have everything, and put the equations. You have to put the 21 here, RHS 21, 24. Here 24. Now we have to find Zj value. So Zj is nothing but dot product of Cbi and this x1, right? So 0 into 3 plus 0 into 4, put it here. So right here the values is nothing but a dot product, 0 into 3 plus 0 into 4, 0. Again here 0 into 3 plus 0 into 3, 0. Here 0 into 1 plus 0 into 0, 0. Here 0 into 0 plus 0 into 1, 0. 21. 21 into 0, 0 into 21 plus 0 into 24, 0. Cj minus Zj. Let us introduce another one. Cj minus Zj. Cj is available in the top. So Zj is available here. So what is Cj minus Zj? Just write as such 10, 9, 0, 0. For optimality condition, for maximization problem, all Cj minus Zj values should be 0, either 0 or negative. If it is positive, then choose the largest, highest value. Right? Now here, the contribution of this 10 is more, right, to the objective function. So I am choosing this 10. So among 4 Cj minus Zj value, 10, 9, 0, 0, the largest one is 10. So choosing this 10, and the corresponding column is called key column, right? This column is called key column, the x1, because we have to, on the next step is iteration 1, this x1 will be entering as a basic variable, and some variables, we have already 2 variables, any one variable is becoming non-basic variable, that is leaving, right? Any one of these basic variables is leaving, and x1 should be entering inside. So first we have decided which variable is entering, that is x1 is entering, and we have to find out which is leaving. So I will go to the next step. Here I have to find the ratio. Ratio is nothing but RHS divided by this key column elements. So 21 divided by 3 equal to 7, 24 divided by 4 equal to 6. Here we have to choose the lowest ratio. For the maximization problem, all Cj minus Zj values should be 0 or negative. If it is positive, choose the positive value, most highest value. Then this column is called key column. find the key row. For finding the key row, choose the lowest ratio. So 6 is the lowest value. So choose this. So x4 is leaving, x1 is entering. So x1 should enter here, x4 leaves. Go to the next. Okay. So this is key row, this is key element. This is entering variable, this is leaving variable. So the intersect in a particular point, particular element is called pivotal element or key element. So 4 is nothing but a pivotal element. Go to the next. So our aim is, I'm just repeating the same thing here. So whatever written in the previous slide, I'm repeating here. So iteration 0 for explanation purpose. In iteration 1, I keep x3 here and I remove x4 and put x1. So here, see the previous iteration 0. Here the basic variables are x3 and x4. You see this x3 and this x3. In this box we have 1, right? And go to the x4, 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 1. So in this row, x3 is 0 here. In this row, x4 is 0 here, right? So we can see 1 0 0 1, x3 x4, x3 x4. So this is the pattern, right? Same way I have to get it here. So here I have x3 and x1, right? The x1 left, x3 x3 1, I should get 1, right? And x1 x1 I should get 1, other I get 0, right? So in order to get 1 here, so already 4 is here, so how to make it 1? So I have to enter a new values here, right? The thing is, take the numbers 4, 3, 0, 1 and 24, divide by 4. So take this key element and divide in all x1, x2, x3, x4 and RHS. So 4 by 4, 1, 3 by 4, 3 by 4, 0 by 4, 0, 1 by 4, 1 by 4, 24 by 4, 6, right? And here, in iteration 0, we have 3, 3, 1, 0 and 21. So this has to be 0. How to make it 0? Right? So here, if you write x1 here, it should be 1, it should be 0. So how to make it 0? Here, come to this right hand side. I have written the same thing here. Whatever written in x3, this is x3, old x3. Right? So the elements are 3, 3, 1, 0, 21. 3, 3, 1, 0, 21. Right? Then come to this particular thing, new x1 value. Right? So multiply with 3. 3 times of 3 minus 3 times of this number. So I'm just writing the new x1 column, sorry, row 1, 3 by 4, 0, 1 by 4, 6. Multiply with 3. 3, 9 by 4, 0, 3 by 4, 18. So take the first one minus this one. So it's the color in brown, right? First box minus second box, so third box, right? So 3 minus 3 is 0, 3 minus 9 by 4, 3 by 4, 1 minus 0, 1, 0 minus 3 by 4, minus 3 by 4, 21 minus 18, 3. So write it here. 0, 3 by 4, 1, minus 3 by 4, 3. Now find out Zj. As usual, 0 into 0 plus 10 into 1, 10. So multiply here, right? Dot products, 14 by 2, 0, 5 by 2, 60. Cj minus Zj. So all are 0 and negative except this one, 3 by 2. So optimality is not reached. So there is a positive value is available, that is 1 by 1.5, 3 by 2 is available. So you are choosing this as entering variable, x2 is entering. Then you have to find out which is leaving. So come to the ratio 3 by 3 by 4, right? 6 by 3 by 4. So 3 by 3 by 4 is 3, 6 by 3 by 4 is 8. Choose the lowest ratio. So x3 is leaving, x2 is entering. Right? Pivotal element is 3 by 4. Yeah. x2 is entering and x3 left. So x2 what is the coefficient is 9, x1 10 as usual, right? So again if we see this should be 0. I tell you, take x2, say x1 1, x2 1. So in this equation this x1 should be 0. In this equation this x2 is 0, right? So 0 1 1 0, this should become. So accordingly you can change it, use the previous method and accordingly we change it. And in RHS we have 4 and 3, right? Then go for Zj value, 0 into 9, 9 into 0 plus 10 into 1, 10. Here 9, 2, 1, 66. Cj minus Zj, 0, 9 minus 9 is 0, 0 minus 2 minus 2, 0 minus 1 minus 1. So we reach optimality because we don't have any positive value, all are 0 and negative values. Right? So what is the solution? X1 equal to 10, sorry, x1 equal to 3 is the solution, x2 equal to 4, z equal to 66. Right? So substitute in the problem 10x1 plus 9x2. Right? What is Zj? 9 into dot product, 9 into 4 plus 10 into 3, 66. So 36 plus 30, 66.